You shouldn't be clueless of the car you are driving. Know your car, and save on repair cost. Fix and upgrade your car parts. Drive with clue. Engine block. 1. The engine block is the main structure of an engine. It houses critical components such as the cylinders, pistons, crankshaft, and coolant passages. 2. It is often called the foundation of the engine. All major engine parts are mounted to or inside the engine block. 3. Engine blocks are usually made of cast iron or aluminum. Cast iron is strong and durable, while aluminum is lighter and improves fuel efficiency. 4. The cylinders are built into the engine block. Pistons move up and down inside these cylinders to create power. 5. It contains coolant and oil passages. These internal channels allow coolant and oil to circulate, preventing overheating and reducing friction. 6. The crankshaft rotates inside the engine block. Bearings inside the block support the crankshaft and allow smooth rotation. 7. The engine block helps control engine temperature. Coolant flowing through the block absorbs heat from combustion. 8. Each engine block is designed for a specific engine size and layout. Inline, V-type, and boxer engines all have different block designs. 9. Damage to the engine block can be very costly. Cracks or warping often mean the engine must be rebuilt or replaced. 10. The engine block determines engine displacement. The size and number of cylinders in the block define how much power the engine can produce. Cylinder head. The cylinder head sits on top of the engine block and seals the combustion chambers. It contains intake and exhaust valves that control air and fuel entry and exhaust exit. The spark plugs, or fuel injectors in diesel engines, are mounted in the cylinder head. The cylinder head helps create compression, which is necessary for combustion. It is usually made from aluminum or cast iron for strength and heat resistance. Cooling passages inside the cylinder head allow coolant to remove excess heat. The camshaft is often located in the cylinder head in overhead cam engines. A head gasket seals the cylinder head to the engine block to prevent leaks. Warped or cracked cylinder heads can cause overheating and power loss. A properly functioning cylinder head improves engine efficiency, power, and emissions. Pistons. 1. Pistons move up and down inside the engine cylinders. 2. They help convert fuel combustion into mechanical power. 3. Pistons are usually made of aluminum alloy to reduce weight and handle heat. 4. Piston rings seal the combustion chamber and control oil. 5. The movement of pistons turns the crankshaft, creating engine rotation. 6. Pistons play a key role in engine compression. 7. Excessive heat can cause pistons to expand or seize. 8. Worn pistons can lead to low power and oil burning. 9. Each engine cylinder has 1 piston. 10. Proper lubrication is essential to prevent piston wear and damage. Piston rings. 1. Piston rings are metal rings fitted around the piston. 2. They seal the gap between the piston and the cylinder wall. 3. Piston rings help maintain engine compression. 4. They prevent engine oil from entering the combustion chamber. 5. Most pistons use 3 rings, 2 compression rings and 1 oil control ring. 6. Piston rings transfer heat from the piston to the cylinder wall. 7. Worn piston rings can cause oil burning and blue smoke. 8. Broken rings can lead to loss of power and misfires. 9. Piston rings must be properly lubricated to reduce friction. 10. Properly functioning piston rings improve engine efficiency and lifespan. Connecting rods. 1. Link between piston and crankshaft. A connecting rod connects the piston to the crankshaft, allowing the up and down motion of the piston to turn into rotational motion. 2. Essential for engine power. Without connecting rods, the force created by combustion could not be transferred to the crankshaft to produce engine power. 3. Operate under extreme stress. Connecting rods endure very high forces from combustion pressure, inertia, and high engine speeds, RPM. 4. Made from strong materials. Common materials include forged steel, powdered metal, aluminum, performance engines, and titanium, racing engines. 5. Big end and small end. The small end attaches to the piston via the wrist pin end. The big end connects to the crankshaft journal. 6. Require proper lubrication. Engine oil lubricates the big end bearing to reduce friction and prevent overheating and wear. 7. Length affects engine performance. The length of the connecting rod influences piston speed, engine efficiency, and torque characteristics. 8. Failure can be catastrophic. A broken connecting rod can punch through the engine block, often destroying the entire engine. 9. Precision manufactured component. Connecting rods must be perfectly balanced and accurately machined to avoid vibrations and engine damage. 10. Upgraded for high performance. High-performance or turbocharged engines often use stronger aftermarket connecting rods to handle increased power and boost.